All right. So welcome to today's discussion. So today we'll be focusing on how to analyze and interpret one sample t-test. With one sample t-test, it is kind of related to z-test. So the last recording that I did, um, I walk you through how to analyze z-test. And we emphasize that with the z-test, there are certain assumptions which are always a sample will be drawn from a population. The dependent variable should either be interval or ratio. And also the population standard deviation and the population mean should be given in the question. So these are the three main assumptions you should find in a question that should inform you to use z-test. But with one sample t-test, the only distinction between one sample t-test and z-test has to do with the fact that with one sample t, the population standard deviation will not be given in the question. Meaning that with one sample t, you should find out, and always a sample should be what? Should be drawn from a population. That's one sample t, like z-test. A sample should be drawn from a population. The dependent variable should be measured on either ratio or interval. However, the population mean should be given, but the population standard deviation should not be provided in the question. This implies that whenever you see in the question that they are comparing a sample to a population, two main parametric tests should come to mind. Because among all the parametric tests that we'll be doing, it's only these two tests that they will compare a sample to a population. So when you're able to figure out that they are comparing a sample to a population, two tests should come to mind, and that's z-test and one sample t-test. After you've been able to figure out this, then you ask yourself, what is the difference between z-test and one sample t-test? And as I indicated, the only difference has to do with the fact that with z-test, the population mean and the population standard deviation should be provided in the question. Whereas with one sample t, the population mean sometimes will be given, but always the population standard deviation should not be provided in the question. So like this example that I've projected on your screen, you can see that there's a question and they've indicated that you're supposed to show full working steps, meaning that you are supposed to use the 6 steps to solve this question. So when you read the first sentence, with the first sentence, they are telling you the following data represents the performance of 10 students in University of Ghana. So the first sentence should give you a clue that we have 10 students from University of Ghana, and you know University of Ghana doesn't encompass a whole lot of students, not only 10 students. So that should signal to you that they have taken 10 students as their sample, and out of this, we have what? A population. So it means 10 students were taken from the population. So that should signal to you that we have a sample being compared with a population, meaning the first assumption has been satisfied. So after you've been able to decipher this, then you ask yourself, the test that I can use could either be z-test or one sample t-test. So what is the difference? Find out Have they provided the population mean and the population standard deviation? If it is provided, then you know that you're supposed to use z-test. But in situations whereby they have provided the population mean and the population standard deviation has not been provided, then that should signal to you that you have no other option than to use one sample t-test. So let's read further. They indicated the population mean of university students is 7.3. Sorry, the mean of University of Ghana students is 7.3. And we were able to decipher that University of Ghana is the population. So it means the mean there is the population mean, meaning the population mean has been given. But when you read further, they didn't state the population standard deviation in the question, signaling to you that you have to use one sample t-test to solve this question. Then they went further to ask or pose a question. What is the possibility that 10 students perform better in statistics than the average university student? This is also serving as a clue to you that they are comparing a sample to a population. So let's try and use the 6 steps to solve this question. So it means that first, we need to follow the pattern. Step 1, choice of statistical test. And as I indicated in my previous video when I was discussing z-test, I emphasized that always under step 1, you are supposed to state the assumptions of that particular test you found in the question. You're supposed to state all the assumptions pertaining to that test. Then you tell us that based on this, you'll be using this type of test. So from the question, we were able to decipher that you are supposed to use one sample T. So it means under step 1, we need to tell our examiner that we'll be using one sample T test and justify why we'll be using it by using the assumptions underlining one sample T test. So when you read, you will see that the first statement that I made, I was trying to tell my examiner that from the question, I was able to decipher that a sample was generated from a population. Then I went further to indicate that the dependent variable, which is performance, is on at least interval scale. Then we were able to decipher that the population mean was provided. So you need to state that as part of your assumption. The population mean was provided, but the population standard deviation was not provided in the question. Then with the last assumption, you just assume, because it's not always the case that within the question they will tell you the scores are in a normal curve distribution. But so long as you know that the scale of measurement is either interval or ratio, that should signal to you that it is a parametric test. Hence, you need to state this assumption as part of your assumptions for all the parametric test. So it means we assume the scores of the populations are normally distributed. So after you state these 4 assumptions for one sample t-test, then you tell your reader that based on this, you'll be using one sample t-test. So that's how you do it when it comes to step 1. Then under step 2, which is statement of hypothesis. And as I've been saying, it's better if you first state your alternative hypothesis. Why? Because with your alternative hypothesis, which is also H1, you can directly find it in the question. Why? Because within the question, a prediction has been made. Currently, we know that they are comparing a sample and a population. So it means within the question, they have indicated what they want. They've indicated that the sample will be greater than or less than, or if they don't state it like that, they will tell you, oh, between the sample and the population, there will be a difference. That should tell you that it is the alternative hypothesis. They've made a prediction. So when you read the last statement or the latter part of the question, they indicated what is the possibility that the 10 students performed better in statistics than the average university student. So first, we should find out what are we measuring? Performance. And they are telling you the sample, which is the 10 students, they will perform better than the population, which is the average university student. So that is your prediction, and that is your hypothesis. And that will be for H1. But in stating this, you're supposed to put it in a statement form, and it's supposed to be in the future tense because it is a prediction. We haven't gone to the field to test it yet. So when you go through, you can see that H1, I indicated the student or the 10 students will perform better in statistics than the entire university student. So this is a typical one-tiled or directional hypothesis. So it means that after you've been able to decipher your H1, you need to ask yourself, this hypothesis, is it directional or non-directional? And how would you know that is directional or non-directional? For a directional hypothesis, always they will tell you one of the members or one of the group will be greater than or less than, or will perform better or worse. So you can see within the prediction, they were specific. They indicated that the sample, which is a 10 students, will perform better than the population, telling you that they are telling you one will be greater than the other. So this is a typical one-tailed or directional hypothesis. For it to be two-tailed, it means that they will state the prediction in such a way that you wouldn't know which of the two groups they are emphasizing to be greater than or less than. So they could have just stated there will be a difference in performance in statistics between the 10 students and the average university student. So when they put it in this fashion, what they are telling you is that, oh, any of the group could perform better or poorer than the other. So they haven't really been specific which of the group will perform poorer or better. They're just saying definitely there will be a difference between them. One will be perform better than the other, but to them, they don't know which of the group. So when it happens like that, then it means you're supposed to use, or the hypothesis in itself is a non-directional or two-tailed hypothesis. And so when you see that the hypothesis is one-tailed, it means that with your HO, and you know the HO is the direct opposite of your H1. So it means that your HO, you're supposed to state two main hypotheses when you see that your alternative hypothesis is directional or one-tailed. So from this analogy, you could see that the H1, we indicated the 10 students will perform will perform better than the average university. That's our H1. With our HO, we indicated the 10 students will perform poorer. So the poorer there is what? Is the direct opposite of better, or will perform worse. Apart from this, we've also stated another hypothesis for HO by indicating that there will be no significant difference. We emphasizing that there will be no significant difference. It's more or less like we telling the reader that between the two groups, their performance will be the same or they will be equal. So it means when it comes to your null hypothesis, you are given all sorts of alternatives that could render your H1 to be false. So since your H1, you are saying the first group, which is your sample, will perform better than the population, then we have to give all sorts of alternatives that could render that hypothesis false. And one prediction that could render it false has to do with the fact that the sample, which is the 10 students, they will perform poorer. Or between the two, that's the sample and the population, nobody will perform better or poorer. So they will be what? They'll be same. So these are the hypotheses you state for your HO. And apart from you stating your hypothesis in words, you're supposed to represent them in symbols. And for you to represent them in symbols, you know, with your H1, we're comparing the sample and the population. And as I've been saying, your hypothesis representing them in symbols, use the means, the mean. So we know the 10 students, they are what? The sample. So it means our symbol for the 10 students will be the sample mean. Then the entire university students, they are the population. So it means we need to use the population mean to represent the entire student. So here comes the case. We emphasize that with the 10 students, they perform better. So it means we are indicating that the sample mean, which is X bar, and sorry, I couldn't get a symbol for the X bar. So the sample mean, you know, the symbol is X, then a bar on top. So we are saying the sample mean will be greater than the population mean. That will be for H1. Then with HO, for the second one, we indicated the 10 students, which is the sample mean, they will perform poorer. So it means this time around, they will be less than the population mean. Then the second HO, we indicated there will be no significant difference between the two. So what we are saying is that with a sample mean and the population mean, they will be equal to. So that's how you represent your information in a non-directional fashion. But in situations whereby your hypothesis was, sorry, in a directional fashion, but in situations whereby your hypothesis was non-directional, meaning that within the prediction in the question, they had indicated what is the possibility that there is a significant difference in performance in statistics between the 10 students and the average university student. Then it means your H1 will be, there will be a significant difference between the 10 students and the average university student. So you saying there will be a significant difference, then it means your hypothesis, you would have represented it as the sample mean will definitely not be equal to your population mean. Then your HO will be the direct opposite of H1. So we would have just stated there will be no significant difference in performance in statistics between the sample and the population, meaning that you would have represented it using this, which is the sample mean will be equal to the population mean. So this implies that when your hypothesis is non-directional, it means you're supposed to state one hypothesis for your alternative and one hypothesis for your null. But when your hypothesis is non-directional, but when your hypothesis is directional, which is one tilde, it means you're supposed to state one hypothesis for your alternative and two hypotheses for your null. But when it is non-directional or two tilde, it means you have to state one hypothesis for your null. Oh, you have to state one hypothesis for your alternative hypothesis and two. sorry. So let me repeat everything. When it is non-directional, you have to state one hypothesis for your alternative and one hypothesis for your null. But when it is directional, it means you have to state one hypothesis for the alternative and two hypotheses for the null. That is basically what you're supposed to do. Always know that. Okay. So the decision rule. That's the third step. And a decision rule, you have to use three main criteria to get a critical value. And you are supposed to compare the critical value with your computed value. And for you to get your critical value, it means you have to know three key things. First, find out whether your hypothesis is directional or non-directional. Then find out the level of significance. Also find out the degree of freedom. So these are the three main things you need to generate your critical value. So from the question, we're able to decipher that our hypothesis is directional and our level of significance, they didn't indicate in the question. And I've been indicating that whenever they don't emphasize the level of significance to use, always use 0.05. Then our degree of freedom. The degree of freedom for one sample t-test is n-1, where in this course, whenever you see small n, it represents the total number of people in the sample. And from the question, they indicated we have 10 students. So it means 10 students will be our sample. So it means we have 10 minus 1, which is equal to 9. So it means that our degree of freedom is 9. Our level of significance is 0.05. And our hypothesis is directional. When you are able to generate these three things, you then go to the formula table. A formula table will be provided. You just have to go through it and find out your T table. And on top, how do you know? Because a lot of table will be presented to you. So how do you know that this is the table that you're supposed to use? Always search for on top of the table. They sometimes indicate some selected critical values of T. When you see T, that should tell you that this table is for a t-test table. So all the t-tests that we'll be doing, we'll be using this table. So first, we're able to decipher that our degree of freedom, this is the degree of freedom. So we have a lot of degree of freedoms, but our focus is on 9 because our degree of freedom was 9. This tells you that you are supposed to select the values which is around this side. So you are supposed to select one of these values. So you ask yourself, which of the values should I select? Because we have 6 different values. that we need to select. To know which of the value out of the 6 to select, it should be informed by whether your hypothesis is non-directional, which is two-tailed, or directional. We're able to decipher that our hypothesis is directional. It means that it is one-tailed. So it means we are supposed to select one of these level of significance. Then again, you ask yourself, they are saying one of these level of significance is what we are supposed to select. We're able to decipher that our level of significance is 0.05. But when you check this, it is in percentage. When you convert 0.05 into percentage by multiply by 100, you're supposed to get 5%. So it means 0.05 is the same as 5%. Hence, we are supposed to select this 5% value. It tells you that you're supposed to read your information around this side. And we knew that we are supposed to select one of these values here. So it means this is the value that we have to select, which is 1.833. So it means we have no other option than to select 1.833 because we are selecting the 5% level of significance and our degree of freedom is 9. So it means you're supposed to select the values which is around this side, and the only value we can select is 1.833 because it falls under the 5% level of significance. So that is how you read your critical value. So right now we know that we are supposed to select 1.833 as our critical value. Okay. So after you've been able to do this, you put this information, that whether it is directional, level of significance, and degree of freedom, you should put them in a statement form. So you trying to figure out whether it is directional, level of, you just put it, you just jot it within your question sheet. But when you are answering it in your answering sheet, you are supposed to put it in a writing like this. Means that the way I have formulated, I'm telling my reader that my level of significance is 0.05, my hypothesis is directional, and this is the degree of freedom that I had. Hence, I'll be using a T critical value of 1.833. So after you've generated your T critical, you then set a rule. And this is a thumb rule for all the hypotheses, all the tests that we'll be doing. So long as your hypothesis is directional and they've indicated that, okay, the sample will be greater than, we are assuming that our value will be positive. So hence, we need to state only the positive decision rule. And I have explained this in details when I was talking about the previous video when it comes to z-test. So when you have issues when it comes to this, kindly refer to the z-test video, and I've given detailed information about the decision rule. So it means we have no other option than to select the positive decision rule and state the positive decision rule. And this is how you state your positive decision rule, by comparing it with your T critical value. All right. So when you are done, then the next thing for you to do is to go to step 4. That's computation. So you realize that when it comes to this course, from step 1 up to step 3, you are not tasked to do any computation, no computation or whatsoever. So under step 4, you compute by using the formula for one sample t-test. And this is the formula for one sample t-test. T is equal to the sample mean, which is X bar, minus the population mean all over the sample standard error of the mean. Okay, so it means for us to solve any of these, we need to find out the sample mean, because the question, the only value that was provided to us was the population mean. It means you have to solve the sample mean and the sample standard error of the mean. And so long as you've been given the data, or you've been given this table, which is the sample data, whatever sample statistics they want you to solve, it shouldn't be a problem. So it means you're supposed to find the sample mean, and you know the formula for the sample mean, sigma x over n. So under sigma x, you are supposed to add the performance value, all their scores together. That will give you sigma x. And when you add, you're supposed to get 80. And you know small n represents the total number of people in the sample. And when you check, they are 10. So it means it will be 80 over 10, which is equal to 8. Hence, our sample mean is 8. So it means that we know our sample mean is 8. And from the question, they provided our population mean to be 7.3. So it means that when it comes to the numerator value, we have all of them. The next thing for us to do is to find out the denominator values. That's the sample standard error of the mean. And the formula for the sample standard error of the mean, you know it to be this: S over square root of n. So it means we need to find S. And for it to find S, this is the formula for S. S stands for the sample standard deviation. So it means we have to find out the sample standard deviation first before we can find the sample standard error of the mean. So this is the formula, sigma S squared. So you know with sigma S squared, it means you are supposed to first find S squared. And how do you find S squared? It means you need to square all the X values, and that's what we've done here. Afterwards, then you add the S squared values, which will give you 700. So that is what is there, 700. Then sigma X into bracket all squared. We already had sigma X to be 80. And you know in math, when a value is in brackets, then it means that you're supposed to solve the one in the bracket first. So when you check, sigma X is in bracket, and we have sigma X to be 80. So it means it will be 80 squared, and 80 squared is equal to 6,400. So it means that our sigma X squared, this, which was not in bracket, we had it to be 700, which is here, which is there. Then the sigma X all squared, the one in bracket, we had it to be 80 squared, which is 6,400. Then you divide it by 10 based on the formula here, the formula for the S. Then you make it all over 10 minus 1. So when you compute, you are supposed to get an S value of 2.581 and so on and so forth. So right now, you know your S value. Hence, you can go back and solve your standard error of the mean, which is S over square root of n. We know n to be the total number of people in the sample, which is 10. So it means our sample standard error of the mean will be 2.581988887 over square root of 10. And that should give you a value of this. So right now, we've been able to generate our sample standard error of the mean. We have our sample mean. We have our population mean. Hence, we can solve T. The reason as to why we went through all these hassle was to solve our T value. Right now, we know all the values for our T, so we can solve them. We had the sample mean to be 8, and The population mean was given in the question as 7.3. And our sample standard error of the mean, we had it to be 0.816 and so on. So it means that when you calculate, you're supposed to get a t-value of this 0.8573 so and so, and you convert this value into 3 decimal place. And when you convert, it will be 0.857. So it means this value, the 0.857, is our t observed. So that will be all for the computation. That will be all for the computation. So when you are done computing, the next thing for you to do is decision. Decision. And a decision, you're supposed to compare the value that you got, which is your 0.857, with your decision rule. So this value that we got under step 4, that 0.857, is the t observed that we mentioned at the decision rule. So let me copy and paste the t observed here so that the critical value here so that we can compare. So we indicated that we are supposed to retain HO if our t observed. Right now we know the t observed, and the t observed is what? 0.857. So we indicated that if 0.857 is less than 1.833, we have to retain HO. But if our t observed, which is 0.857, is greater than or equal to 1.833, we have to reject HO. So you ask yourself, this 0.857, is it greater than or less than 1.833? And you could what? You could obviously see that 0.857 is less than 1.833. Hence, we have to retain HO. So when you're able to decipher this, and at step 5, this is how you put it into writing. Comparing your T observed with your T critical, where your T observed is 0.857, you can see your T observed is less than 1.833. Therefore, you have to retain HO. That's how you put it. Then the last thing has to do with interpretation. With interpretation, based on your decision and at step 5, you either retain or reject HO. So interpretation has to do with the fact that we have 2 main hypotheses. You have to select one of the hypotheses as your answer. So for us to select one of the hypotheses, we need to solve and go through all the hassle. And we've made a decision. The decision will inform us to whether to accept one of the hypotheses. That's whether to accept HO or H1. And per our decision, we are retaining HO. It means that under the interpretation, we should state the HO hypothesis because that is what we are accepting. So you go back to step 2. What did you state for HO? You could see under step 2, we stated 2 main hypotheses for HO. So it means you need to state all the 2 hypotheses as your interpretation. But this time around, you wouldn't put it in a future tense, but rather in a present tense. And that will be all for this. So these are the basic steps you need to go through, or you need to go through whenever you are solving one sample t-test. So that'll be the end of today's discussion. Thank you very much.